All right, good morning. Happy Tuesday. Hey, I hope the exam went okay. I haven't had a chance to look at it.
No.
But just a reminder, a couple things. Remember, you're expected to read the problem and give the answer the way they're requesting. And also, if you ever do a problem and you feel like you did it correctly, don't hesitate to, and they marked it wrong, don't hesitate to send me a message and I can take a look at it. So I'm not standing here saying everything on that automated system is correct. So there is an advantage. When you take a math class, you want to take it early in the morning. So this is for college, okay? And the reason why you want to take it early in the morning is because your brain is fresh and it's requiring a lot of thinking. So a lot of times fifth period isn't good. It is okay with this distance learning, but if we were actually in school, it's the worst time to take a math class. And the reason why, does anybody know the reason why fifth period is the worst period to take a math class? So you get lunch, all you feel like doing is taking a nap. So you don't ever want to take a math class after lunch. So a couple of announcements. Make sure you watch the announcements because I made a video because I'm staff of the month. And so I'm actually singing with a bunch of ducks. And so you'll have to check it out when I post the next, a weekly announcement video. There's a lot of good information on there besides me making a fool out of myself. They're giving global news, local news. They're talking about the clubs on campus and the sports, things that are going on. So I am posting it in my classroom. So make sure you watch the video announcements, especially next time, because I have a few words to say to my students. So check it out. Sorry about the glitches last week. I'm not sure what was going on. I still don't know what's going on because my laptop is saying that my internet speed is fast. So I don't know what's going on. And it's hard to detect what's happening, but hopefully I can get it figured out and resolved as quickly as possible. Now, one of the advantages about taking math fifth period is I have had third period and fourth period already, and I figured out all the problems they have with their math. So first of all, lesson 12.1 is in the new volume. So remember I told you to go get volume 2? So lesson 12.1 is in the new book. And I do want to clarify some stuff because today, after I finish the lesson, we're going to work on practice AB, and a lot of the answers are written incorrectly. So the moral of the story is make sure you follow your notes. So they're not writing the domains correctly. They're not simplifying the rules. And so, yeah, I'm gonna go over that in a minute. But I hope the exam went well. So. Okay, anybody want to ask me any questions about the exam or anything else right now before I finish the lesson on 12.1? Okay. Last week, I was talking about arithmetic sequences, which I'm not supposed to be teaching in Algebra 2. That's an Algebra 1 standard, but it's okay. We talked about writing explicit and recursive rules. And you saw that recursive rules are requiring a previous term. We also looked at graphing arithmetic sequences. And today what I'm going to do is I'm going to do a couple of real life problems. So you can see how these arithmetic sequences apply to real life. And the first problem I'm going to do, I feel like I see it everywhere. I feel like I've seen it on the SAT, the ACT. I feel like I saw it on my teaching credential exam. I feel like I've seen this problem everywhere. And it's an arithmetic sequence. And so I only have two problems to do. Then I'm going to do the first problem in practice AB, since nobody last period was doing it correctly. All right, so let me give you these two problems. Take, you guys can you guys look? Is it page 588 in your new volume? Page 588. Is that the correct page? It's talking about the rows in a theater. Yeah?
Yeah, it's 588.
Okay. So this is the problem that I feel like I've seen all the time. So let me read it. It says, now notice what the directions say write a recursive rule and write an explicit rule, and then they want you to solve it. Now, they're going to want you to find how many seats are in the 13th row. Now, they do tell you to use the rule. So if you draw out a little picture and figure it out that way, you're not going to get credit for it on an exam. And the reason why is because if I asked you for the 97th row, you wouldn't be able to figure it out. So if you're wondering, why do we have to use this rule? We can figure out the 13th row. Well, the 13th row isn't the real issue. The real issue is if I asked you to give me the 213th row, you would need math to figure it out. Okay, so let me read the problem. It says there are 19 seats in the row nearest the stage of the theater. Each row after the first has 2 more seats than the row before it. How many seats are in the 13th row? Now, make no mistake that we can find any number of seats in any row once we have a formula. So once we have a rule, we can find the number of seats in any row. So the first thing we're going to do is we're going to find the common, because we can't use the rules unless we have a common difference. What's a common difference, guys? What's a common difference mean? Doesn't it mean the same when you subtract the successor minus the previous term? So where did I get this from? I got it from the reading, because they said that the first row was 19 and that it has 2 more every time, right? So the common difference would be 21 minus 19, 23 minus 21, 25 minus 23, and 27 minus 25. So the common difference is 2. Let me pin myself real quick. If I gave you this exam in class, if you don't show me this, you get a point off. So you have to show me that you can find the common difference mathematically. Make sure you go this way, not that way. If you went this way, it would be a negative, which is going to mess up everything. So if we look at the explicit rule, you actually have 4 rules. You have the first 2 rules start with a position of 1, and the second 2 rules start with the position, the first 2 formulas are with a position of 0, and the second 2 are position of 1. So I'm going to use this one. Now, I'm gonna explain this right now, and I need you to pay attention. This is multiplying. So this is D times N, the quantity, D times the quantity N minus 1. All right, so if I was doing this, the first term is 19, the common difference is 2, and guess what? Practice AB is leaving this like that. If you look at the answers, they're written like that. Now, your online exam, it might be written like that, but I'm not assuming you know how to distribute. And we want to simplify this. So forget the online exam, forget everything. You do want to simplify this to this. So that is the rule. And you would say n is greater than or equal to 1. And the reason why this domain is not restricted is because we don't know how many seats there are in the theater. Now, when I give you this, see how the domain's restricted on number 1? It should be n less than or equal to 5 and greater than or equal to 1. But the answer key doesn't show that, so that's wrong. So when you have a table that's finite, you have to restrict the domain. So the domain would be n greater than or equal to 1 and less than or equal to 5. So now we go over here to the recursive rule. And this is going to be f of n is equal to, now remember over here, pay attention. Remember I said this is 2 times the quantity? This isn't f times the quantity. This is a function of n minus 1. Two different things going on here. This is the distributive property. That is a function of n minus 1 plus d. And notice that the recursive rule is one more than the explicit for the domain. So when we write the rule, it's going to be f of n minus 1 plus the common difference for n greater than or equal to 2. But watch what I'm going to do here. I'm going to say that f of 1 is 19. And it's like, hold on, Miss Birch, what are you doing? Well, this rule is completely useless if you don't have the first term. Remember, you need the first term. So when I put in 2, see the domain? When I put in a 2, it's going to be f of 1, and I need this. So shouldn't I write it? Well, it doesn't say that on the answer key. I don't care what it says on the answer key. You need the first term to do the recursive rule. All right, now, they want to know how many seats in the 13th row. So I always use whenever I can use the explicit rule, I'm going to use the explicit rule. So I simplified this down to f of n is equal to 17 plus 2n. So isn't that better to use than that? Because it's simplified. And now we want the 13th row. So this would be 17 plus 2 times 13, which would be 17 plus 26, which is 43. So we would say there are 43 students in the 13th row. So what am I trying to tell you? I'm trying to tell you this book is not consistent, and we don't care if the book has wrong answers or it's inconsistent. We always want to do correct math. So the reason why there's no restriction on these domains is because we don't know how many seats there are in the theater. And yeah, we could do this by hand, but if I asked you for the 133rd row, you realize you can use this formula for the 133rd row, right? You could use it for the 500th row if we needed to. So life easy. Okay, anybody have a question about this before I erase it? All right, now the next problem has to do with a person who purchased a bicycle but took a loan from their parents. So they're paying back the parents periodically, and they want to know how long it's going to take for this person to pay for this bicycle. So take a look at page 589B. And they want you to do the same thing. They want you to write an explicit rule and a recursive rule and then solve the problem. All right, here it is. A student with a part-time job borrowed money from her parents to purchase a bike. The graph shows the amount the student owes her parents as she makes equal weekly payments. That means arithmetic. The amount owed is shown only for the first few weeks, the first 5 weeks. And how many weeks after purchasing the bike will the loan be paid off? And notice this graph starts at 0. It doesn't start at 1. So that means we're using the formulas that start at 0. So the first thing we're going to do is we're going to write the sequence and make sure it's arithmetic so we can use these rules. We can't use these rules if it's not arithmetic. So at the 0 position, we have what, 800? I'm looking at the graph, by the way. What's in the first position on the graph? 750? Who's in the second position? 700? You guys follow me? So do y'all see where I got these from the graph? All right, so I'm going to see if there's a common difference. And remember, you have to find the common difference this way. Don't go the other way. So this is 750 minus 800, 700 minus 750, 650 minus 700, 600 minus 650, and we get negative 50, negative 50, negative 50, negative 50. And if you go the other way, you're going to get a positive 50 and everything's going to be wrong. So we want the explicit rule. And this time, the starting position on the graph was 0. So this is what our rule looks like. So remember, you have 2 rules, right? For starting position is 0 and 2 rules for a starting position of 1. There's 4 rules. All right, so here we go. So this is f of n is equal to, that's the starting initial term, which would be 800 minus the common difference times n. And this time we're done because there's nothing to simplify. Notice I put the domain. For the recursive rule, For the starting position of 1, we have f of n. And this is, like I said, that is not f times. That's f of, it's a function, n minus 1 plus d. And notice the domain is 1 more than the explicit rule. So last time, we started at 1, and the recursive rule was 2. This time, we're starting at 0, and the recursive rule is 1 more. All right, so our recursive rule is f of n minus 1 minus 50, where n is greater than or equal to 1. And like I said, you want to write the first term because this rule is worthless without it. So notice when you put in a 1, you get f of, should be f of 0, right? Yes. So see when you put in a 1, this would be f of 0, which is requiring the first term. So like I said, in practice AB, you're not going to see it written like this. But I don't care. We want to write correct math, not with the mistakes they're making in the book. So now, how long is it going to take her to pay it off? How long will it take to pay off the loan? Now pay attention to this one. I'm using the explicit rule. We don't have the 13th row. We don't even have n. We're trying to find n. We want to know when the loan is at $0, don't we? See how it's different? So in the previous problem, we wanted to find out the 13th row, which was n, the position. Now we want to know when this loan's going to be paid off. We're setting the amount set equal to 0. And we're solving for n. So when you subtract 800, I'm going to multiply both sides by a negative. In addition to that, I'm going to divide both sides by 10. Divide by 10, solve for n. So 5 times what is 80? 1 with 3 remainders, 16. So we can say the loan to the parents will be paid off in 16 weeks. So a little bit different than the previous problem. So here's my word of advice. Should your domain go forever, or should you restrict it? Are you gonna just look at the answers and assume they're right when they're wrong? Or are you gonna do correct math? So we're gonna go into the wizard teams, and they are gonna change. Now that we've taken this exam, I will change them soon. But I'm gonna do problem number 1 since everybody was messing it up last period. So you're gonna work on this in the math wizard teams. Now, look how poorly this is written. Look. Do you see how the positions are 1, 1, 1, 1, 1, 1? Shouldn't they have done like 3 with the starting position of 1 and 3 with the starting position of 0? So this is making students think that there's only 2 formulas, and there's not 2 formulas, because if this starting position was 0, you would use 2 different formulas, right? All right, so I want to do this problem. So this stuff is not hard. but you want to really try to understand conceptually what's going on. So you're getting things right. And in college, if you have a book with the correct answers, you're going to know what you're doing. Okay, this is off the practice, and this is how I want these tables done. Here's number one. This is practice AB. So n is the position, f of n is the term. So you have 1, 2, 3, 4, 5. So notice how there's a restricted domain. This does not go 6, 7, 8, 9, 10. This goes from 1 to 5. And the terms are 8, 12, 16, 20, and 24. And it says, write an explicit rule and a recursive rule. So I'm going to find the common difference first so that I know I can use the rules. Remember, you can't use these if it's not arithmetic. And let me ask you, do I write 8 minus 12 or 12 minus 8?
12 minus 8.
Right. And you have to do it like that, right? And if you're wondering, why does she always do all four? Why does she just do the first one? Because you know what? I've seen tables that have a common difference, 2, 2, 2, and go to a 3. So that's why you're seeing me do all of them. So this would be what? 4, 4, 4, and 4. So the common difference is 4, which makes it arithmetic. So let's write the explicit rule. And if you're wondering, why does she always write this? Because if you were writing, if you were doing an exam in person with me, if you didn't do this, I'd take off a point. Because I want to know, can you show the math? All right. So since we're starting at 1, which rule are we using? We're using the rule where the starting position is 1, right? Not 0. So aren't we using this one? Yes or no? And I might as well write the recursive rule. Is this right or no, guys?
Yeah.
Yes.
Okay. And remember, this domain is one more than this domain. Who can read this to me? Who can read that right there? What does this say? So I want one person to read that, and I want one person to read this.
Is it
Who wants
after the
to try?
quantity n minus 1?
Say it again.
After the quantity n minus 1?
This one is d times the quantity.
Times, yeah, there you go.
D times the quantity. And what's this one?
F times the quantity of n minus 1?
F, no. This is d times the quantity n minus 1. This is f of n minus 1. This is a function.
Oh, okay.
This is the distributive property. That's a function. In other words, this is going to be using a y value. It's a function. Function is y, right? All right, so we have f of n on the first problem. The first term is 8. The common difference is 4. And your book is going to leave it like that, and your exam might leave it like that. But if you're with me, I want you to simplify it, which would be what? 4 plus 4n? Yes or no? So what's going on? Well, the book is assuming You know how to simplify. I don't want to assume that. And you shouldn't be using this to evaluate or find a problem. Now pay attention, because your answer key is wrong. What should this be? Shouldn't it be n greater than or equal to 1 and what? What did I put in the notes?
5 to 5.
And like I'm telling you, your book, your answer key is not writing it like that, but that's correct. Over here, you have f of n is equal to a function plus the common difference. And that is simplified. And that's a function, so you don't want to try to distribute. That doesn't make any sense. But what's the domain over here? It has to be greater than or equal to 2 and less than or equal to what? 5? And isn't this completely worthless if you don't have f of 1, which is 8? Because look up here. If you put a 2 in, wouldn't this be f of 1? Well, don't you need f of 1 to use the rule? So shouldn't we write it? Okay, this is correct, ladies and gentlemen, and this is what you should be writing. You have a table that begins and ends. You should have a restricted domain. So your answer key left it like that. It's incorrect. It should be written like this. And the problems in your book will require this. It's just on the practice AB, they're doing it wrong. All right, anybody have any questions about what I'm talking about? Okay, once again. How do you say this?
D times the quantity n minus 1.
D times the quantity. And how do you say this?
F of n minus 1.
F of. It's a function. See, look, when you put in a 2, you get f of 1, which is requiring the first term. That is a y value. So you're evaluating a function. All right, I'm going to be taking attendance in the Math Wizard teams. I do want to, last period, I was working with the team for so long, I forgot to report back. But we are going to report back here at 12:05, or let's report back at 12. All right, so we're going to report back at 12. Back to WebEx. Now, I really hope that in your teams, you are truly collaborating and fixing each other's problems so that you're not all doing them incorrectly. All right, okay, I'll see you in your teams. All right. Make it back. Okay, I just want to talk about the word or the words common difference. Common means the same. Difference means subtract. So if you had a problem like this, we don't know if it's arithmetic or not, but you would take -8 minus 1, right? So you're going backwards. This would be -17. That's the difference. And the number is -8. So then you have -26, the difference, and -17, and -35, and the difference, -26, correct? Let me make sure that you're clear about something. A negative and a negative is a negative, and you add. Two negative symbols are a positive. So I'll say it again. Two negative numbers is a negative and you add. Two negative symbols are a positive. In logic, there's a class called philosophy, logic. That negative means not. So you could say negative 17, not negative 8. So if it's not negative 8, it's positive 8. Get it? So this would be a negative, and a negative is a negative and you add. This would be a negative and a positive, depends on the sign of the bigger number, and you subtract. A negative and a positive depends on the sign of the bigger number, and you subtract. And a negative and a positive depends on the sign of the bigger number, and you subtract. So the common difference is negative 9. Right?
Yeah.
All right. Do any of you want to ask me any questions about anything?
For me, I think I was having trouble with number 8, the word problem.
It didn't sound like you were having trouble.
It's because I know the first term has to be 100 because it says in month 1 and it starts off on 1.
The first term is 100.
But then after it says she pays it back in $50 payments.
So what you're going to do is you're going to write out the first 5 or 6 terms of the sequence. So you're going to write down 100. And that would be position 1, right? Okay, what happens the next month in month 2?
$50.
So what would you write?
$50 for the second term.
Is that right? Class? Is that right?
Yeah.
So what would the third be then?
0.
I'm not sure about this. Anybody have anything different? So they wanted you to write an explicit rule. What would the explicit rule be?
F of n equals a plus d times the quantity of n minus 1.
And that's when you have the first position. Yeah? It should be 100 minus 50 times n minus 1. What did the answer say?
Answer, it said f of n equals 100 plus 50 times the quantity of n minus 1.
So something's wrong with our logic because this says plus 50. So either it's wrong or we wrote it down wrong. Which is it? Now, it might be that the problem is worded bad. Because does it mean that she paid back 100 in the first month, and then each month after she paid $50 more? Or what, how, is this right?
Probably adding to the 100. So for the second term, it'd be 150, and then going up from there.
So to me, I don't know about you guys, but give me some feedback. I don't know if this is written good. I don't know if this problem is written like it should be written. It's not clear. What do you guys think?
Yeah, I didn't really understand how it was, like how it meant to be written.
And I don't think that's your problem. I think the problem is poorly written in what they intended you to do. So this would be 50, and this would be 50, so your common difference would be 50. And so what they're doing is they're adding 50 to the previous number each month. And if you think about it, that makes sense, but that's not what they said. So like the first month, she paid 150, and the next month you add 50, but you're adding 50 to the 100 because they're accumulating it. You get what I'm saying?
Yeah.
So I think personally, I think the problem is poorly worded in what they meant to say.
Okay, because I thought it was like the other way around, and yeah, that was confusing me.
So they should have said something different than what they said. They should have said something like, okay, she pays 100 back in the first month. In each month after that, she's paying 50 more as she accumulates, or something where it looks like you know how to write this sequence like this and not just add 50 or subtract 50. So
Yeah, that makes sense.
But here's the deal. If you think of the problem, and you guys don't have loans, so you don't know how this works. It says that they want to for the total amount that she had paid back. So this would represent a total amount that she paid back. She paid back 100, and then when she paid 50 more, it'd be 150. So see how it's accumulating what she paid back? All right. Well, good job today. Make sure that you're paying attention to your domain, and that if it's a table, you're restricting it, because be on the exam and in your lesson like that. And I hope you guys have a great day. Okay. All right. Have a great day, guys.
Great day, Miss Birch.
Thank you, April. Thanks, guys. Have a good day. Bye, guys.
Bye, Miss Birch.
Bye, Leslie. You guys have a good day.